Section 8.7, more about graphing quadratic functions, and in this video we'll take a look at finding the x and y intercepts of a quadratic function. In this example we're given f of x is equal to x squared minus 4x plus 4, and for us to find the x and y intercepts, let's identify what the coefficients of the terms are for the quadratic function ax squared plus bx plus c. So here we have a is equal to 1. We have a subtraction where we need a plus, so it would be plus a negative 4. Our b then, which is the coefficient of our linear term, will be a negative 4, and our constant is 4. So to answer the x-intercept, for the x-intercept, we can either factor or use the quadratic formula, because essentially when we're after the x-intercept, we are letting f of x, which is just the function notation for y, equals 0. So we're setting our equation equal to 0 and solving this. And as a shortcut, even though it's a preliminary step, it ultimately will be a shortcut to consider looking at the discriminant to determine what the nature of the roots are going to be and our course of action to solve. The discriminant is the quantity underneath the radical b squared minus 4ac in the quadratic formula. So calculating that out, our b is a negative 4. We will square that. Minus 4 times a, which is 1, times c, which is 4. Well, negative 4 squared is 16. 4 times 4 is 16, and 16 minus 16 is equal to 0. What this tells us is that we will have one real root to this solution, which translates into one x-intercept. And we can then use a number of ways to determine that. We can use the quadratic formula, or if we look at this equation, can we factor it? If we set it equal to 0 to, again, answer the question of our x-intercepts, letting f of x or our y equals 0, we have x squared minus 4x plus 4. The first term is a perfect square x. The last term is a perfect square 2. Multiplying those two together and doubling it gives us the middle term. This is a perfect trinomial square, factoring into x and 2 in the beginning and last term. Both signs are the same, both are negative. Using the 0 property, that means x minus 2 equals 0, or x minus 2 equals 0, which we already have. Adding it to both sides, we end up with x is equal to 2. So long story short, the x-intercept will be at 2, 0. This parabola will only intersect the x-axis in one point, and it will be at 2, 0. To answer the y-intercept question, when we're after a y-intercept, we let x equal 0. The zeros will cancel out the first and second term and leave us with a y coordinate of 4. In standard form, it is 0c for the y-intercept, and in this case, we will end up with the point 0, 4 for our y-intercept. In this next example, they're asking us also to identify the x and the y-intercepts. To move us along this line, let's identify what the a, b, and c are for this quadratic function. So we compare it to the standard form of ax squared plus bx plus c, where a will be 1, b will be a -6 using the rule of subtraction, and c will equal 13. To find the x-intercept, we will let y, which is our function notation here, equal 0. So we have 0 is equal to x squared minus 6x plus 13. To move us along, we're going to calculate the discriminant value to tell us if we're going to have an intercept before we go through all the trouble of either factoring or using the quadratic formula. So taking b, which is a -6, and squaring it, subtracting 4 times a times c will give us a 36 when we square the -6. Multiplying of 4 times 13 is 26, or try it again, 52, and subtracting it from 36 ends up giving us a -16. Since the discriminant is negative, it means we have two imaginary conjugate roots or solutions, and we are only graphing under the real number system. Therefore, there will be no x-intercept for this graph. Since a is positive, this parabola is going to open upward. I don't know the location of the vertex, but what it's telling me is it's opening up somewhere and has some kind of shape to it. It's not intersecting the x-axis at any point because of having two imaginary conjugates for the solutions of this equation. The second question does ask us for the y-intercept, which means we're letting x equal 0, and we can solve that and find that it's 13, or recognizing from general patterns that it's going to be the point 0c, which we've already identified. So this parabola would be intersecting here. Again, I don't know where the vertex is. It could be way over here to the left, but the y-intercept would be at 0, 13. Let's look at one more example. Same questions, they're asking us for the x and the y-intercepts. So comparing this to the general quadratic function ax squared plus bx plus c, our a is a 1, this parabola is opening upward. We have a -9, so we'll call that plus a -9. B has a value of 9, and since there's nothing being added on, c has a value of 0. To find the x-intercepts, we let f of x or our y equal 0. So we have 0 is equal to x squared minus 9x. We can use our discriminant to determine what the nature of those roots are, which is b squared minus 4ac. b being a -9, we'll square it, minus 4 times a times c, which is 0. We end up with nothing being subtracted, but simplifying, we have a -9 squared is 81. This is a perfect square, which is 9, meaning that we can use factoring to solve this. We're going to have two real roots. They will be rational, and as I said, this, because of the location of b squared minus 4ac in the quadratic formula, it's from underneath the radical, square root of 81 is 9, means factoring would probably be the fastest route, or we can use the quadratic formula to find those particular x-intercepts. I'm going to factor the equation. There's only two terms. We have a common x. Factoring out an x leaves an x minus 9, and using the 0 principle, either x equals 0 or the x minus 9 equals 0 for these two things to multiply together to give us 0. Well, there's nothing to be done here. On this option, we can add a 9 to both sides, and we end up with the solution x is equal to 9. So to finish off the question, what are our x-intercepts? X is 0 when y is 0, or x is 9 when y is 0. So we have 2 points of intersection on the x-axis, and to answer the question, what is the y-intercept? The y-intercept is letting x equal 0. They're going to cancel one another out here, both terms, giving us 0. Or, relying on the relationship 0c for our y-intercept, is still going to give us that point of 0, 0.